So in this part, I'm going to show you how to make an engine mount so you can put the bottom of the rocket there, and then how to configure the payload bay to put a little payload inside of it, and how to build the recovery mechanism. From there, we will redo the simulations and then measure precisely where the center of gravity and the center of pressure have to be. And then from there, we'll be able to set up for a launch. So there's an example of a motor we're going to use. It's an Estes E model. There's E12-4 and there's E9. I prefer to use the E9 because they don't blow up as often. What we're going to do is we're going to build two rings. These rings are going to have the same diameter as the rocket body itself, and the inner diameter is going to be just enough to fit this rocket. So we're going to have the two rings made out of balsa wood. That's 5mm balsa wood and 5mm MDF. So just go and mark those out and cut them out. Right, now I've drawn the two circles I want to cut out. One's on the MDF, as you can see there, and one's on the balsa. The reason is the balsa ring's going on the further end of the engine itself, and the MDF piece is going to go on the front end or the business end of the rocket. We're going to use the MDF part to secure that to the actual rocket body itself via 3 screws. So I'm going to go ahead and cut this with a jigsaw and cut this with just a blade, and then we'll get back to you when it's finished. From here you can either use sandpaper to sand it all down to the edge, or just use a Dremel tool. Right, so we've cut the balsa ring, and this will go at the other side of the rocket, so the rocket where the ejection charge is located, like that. We'll then glue it on. So now we're going to cut the front ring out of MDF. We've got the MDF ring cut as well, and we'll just try and fit that on. It's a little bit tight, just need to sand down just a little bit more and be able to fit that and then glue it onto the motor. And now it's complete, we just slot it in to the business end where the rocket exhaust is going to come out of, like that. There you go, nice snug fit, and we'll just apply PVA glue on all the sides here and this side here, and then we'll repeat the same step with the balsa part there, and we'll glue it like that. Now I'm not entirely impressed with how that came out. It's just a little bit loose, so I'll be getting a very thin piece of cardboard and then gluing it to the outer edge of this ring here. That way it forms a tight fit. And that there is a much better fit. So when we apply the PVA glue, we'll apply copious amounts, that way it soaks into the cardboard and the balsa wood, forming a really strong bond. I've done this many times before, that's not an issue at all. Now once that's done, that is your engine mount complete. That's ready to be slotted in the back of the engine. We will secure it to the engine body via small screws. You're going to have 2 screws either side, or 3, just to make sure the engine doesn't pop out at all during the ejection charge. And you don't want to have a loose end, and you don't and you don't want to have a loose engine anyway. Application of the glue is straightforward. Motor ring mounts have all dried up. And then just show you an example of how it should really fit into the back of the rocket. Like this. And then there. And we're going to put some screws here and there to secure it really tight. But it's a really good fit, and I'm happy with that as well. For the payload bay, we're going to put a little screw here with a loop. It's going to be attached to a cord and then attached to a shock cord, which is going to be a really long rubber band. and then it's going to be attached to a parachute, and then from there attached to the body itself. That way when it does all deploy, this will come attached to the body and to the parachute at the same time. That way they'll both descend nice and slowly. Now to do that, I'm going to use the hooked screw from earlier on, and I'll just use some pliers to mend that loop back in. I'm just going to put it into the payload bay itself by screwing it in. Parachute's one of the only pieces I've purchased. It's just easier than having to build one. So this particular one, it's got loops that go around, connect all these loops together, and then tie them up with nylon thread. The nylon thread I'm using is 2mm thick kite thread. I've had a lot of success with this. It is very, very strong. You won't be able to cut this with anything except for a blade. So I'm going to go through and connect all the parachute cord anchor points together, and then we'll tie it to this thread. And once you're happy, just give it a firm pull from the top of the parachute, and then just tie several knots. This is the elastic band I'm going to be using to act as a shock cord. It is just your braided elastic from the local textile store. And what I'll do is I'm going to loop one side of it around like this, and then staple it twice, and then attach this side to the parachute. And the reason for the shock cord is so when the parachute suddenly opens, it doesn't actually break the parts the rockets is actually attached to. So this side here will attach another piece of cord and then onto the rocket body. This side here is already attached to the parachute, and then from here as well will be the actual payload bay. We'll just attach that to it as well. That way the payload bay and the parachute will both impose a force onto the rocket body, and then from here we'll cut from the 50 centimeters of nylon kite cord. So securing the cord onto the rocket body, I'm going to make this very small hole in the actual payload bay here, the sleeve. I'm going to pass the cord through the actual sleeve and then outside, loop it around and then tape it and then glue it onto the actual sleeve itself. I will then glue the sleeve onto the body itself or tape it. That way when the parachute does open, it imposes a force onto the sleeve and then onto the rocket body rather than the sleeve just flying away. So I've managed to slot in the cord and just replace the sleeve there, and then what we can do is we can apply a very thin layer of super glue there, and then a little bit of tape just to secure it. And I'm going to apply some glue to the sleeve here, that way permanently fixing it to the rocket itself. So just glue the sleeve onto the main body itself, and there you go, there's the shot, and you can see the shock cord here, pulls through onto the sleeve, and the sleeve is glued onto the rocket. And the shock will be absorbed by the elastic band itself, which is then attached to the parachute. So I got the main parts laid out. You got the rocket body and the payload bay and the parachute. The payload bay and the parachute both share the same anchor to the shock cord, and then from the shock cord directly to the rocket body via another cord there. So before we actually pack up the recovery mechanism and the payload bay, we're going to cut out some wadding, and the wadding stops the actual fire from the ejection charge from blowing through and burning the components as it pushes them out. This wadding was made by myself. All it was, paper towels soaked in water, mixed in with bicarb soda. You just let it dry, and it produces flame-proof paper towel, and you can use this to protect all the other components against the ejection charge. So I'm going to cut about 3 or 4 circles and put them down the tube, and I'll just make a little ball out of this and then shove it down the actual aluminium tube itself. So as you can see, I'll put some at the bottom of the payload bay. Now, this is almost ready, so what I'm going to do is I'm going to put this cable through here, and then along with the shock cord, and pack up the entire recovery mechanism, because that's ready to go. And with the parachute itself, just pack it up lightly, not too tight, and then give it a light wrap, and then push it down the sleeve once again, and with the cables or with the thread that's remaining, just slot them in. Now you've got to be careful, if this is not done properly, you will find yourself in a situation whereby the parachute gets caught up with the shock cord, and then it doesn't open, and then the rocket. So I'm happy we have enough wadding to protect the parachute, to protect the threads from being burnt as the ejection charge punches through. And that there is a recovery mechanism packed. So something else we've also achieved is we've finalised the actual length of the entire rocket, as you can see. So we will go through the rocket simulation program, and then we will recompute the centre of pressure based on the new length. We'll mark it out, and then we will add the rocket motor onto it, and then conduct our final centre of gravity and centre of pressure calculations to make sure it will be stable during flight. The rocket's coming together very nicely. And the centre of pressure is over here, which is 66 millimeters from the nose cone. So now we've got to make sure it is stable, and to make sure it is stable, the centre of gravity, that is the balance point, has to be at least 5.5 centimeters in front of the centre of pressure, and that makes sure it'll provide a stable flight. For this case here, it's a little bit beyond that, so we have already a stable flight, even without having to add mass to the payload. Alright, so we already determined the centre of pressure is over here, and the centre of gravity has to be at least 5.5 centimeters in front of the centre of pressure, and that happens to be the tube's diameter. And then we'll just try and see where it balances. It balances about there, which is well beyond where the centre of gravity is supposed to be, which means this rocket is actually very stable and is ready for flight. All we have left now is to put 3 screws around the centering ring for the engine, and the rocket's good to go.